Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our final lesson on oxides. Over the last few lessons, we have learned about acid, basic, and amphoteric oxides. We learned that acidic oxides are oxides formed by the chemical combination of oxygen with non-metals. Basic oxides are oxides that are composed of metals and oxygen, and amphoteric oxides are oxides that display both acidic and basic properties. In today's lesson, we will learn about two more types of oxides: neutral oxides and peroxides. We will define both of these and discuss their chemical properties. We will also look at some examples of each, and we will distinguish peroxides from other oxides. Let us begin by discussing neutral oxides. There are only a few neutral oxides. The word neutral refers to the fact that these oxides react neither with acids nor with bases to form salt and water. Therefore, these oxides do not display basic or acidic properties. Examples of neutral oxides include water, carbon monoxide, nitrogen monoxide, and dinitrogen monoxide. Let us move on with our lesson by discussing peroxides. Peroxide can best be defined by the ways in which it is different from other oxides. In acidic, basic, amphoteric, and neutral oxides, the oxidation state of oxygen is -2. In contrast, it is -1 in peroxides. The two oxygen atoms in peroxides are linked together as well as with atoms of other elements. They contain the peroxide link. In the other oxides that we have discussed, the oxygen atoms are linked directly with atoms of other elements. The structure of the hydrogen peroxide molecule, for example, looks like this. Students, can you think of any peroxides? You might be thinking of hydrogen peroxide, sodium peroxide, calcium peroxide, barium peroxide, or even strontium peroxide. Most peroxides of metals, such as sodium peroxide and calcium peroxide, are formed when the metal is burned in the presence of a sufficient amount of oxygen. Peroxides are powerful oxidizing agents. They react with different substances by losing oxygen. For example, when lead sulfide reacts with hydrogen peroxide, lead sulfate and water are formed. When potassium iodide and sulfuric acid react with hydrogen peroxide, iodine, potassium sulfate, and water are produced. The oxidizing powers of hydrogen peroxide in specific make it effective as an antiseptic for cleaning wounds and for mouthwash. It is also used as a bleaching agent. When hydrogen peroxide is added to a colored dye, it oxidizes the molecules responsible for the color. Therefore, the color disappears. For example, students, if you took a black piece of clothing and poured hydrogen peroxide on it, you would end up with white spots where the hydrogen peroxide was applied. Black dye contains lead sulfide. When it reacts with the hydrogen peroxide, it becomes lead sulfate and water. Peroxides also react with aqueous acids to produce hydrogen peroxide. For example, sodium peroxide reacts with hydrochloric acid to form sodium chloride and hydrogen peroxide. Calcium peroxide reacts with sulfuric acid to produce calcium sulfate and hydrogen peroxide. Students, we have been discussing the chemical properties of peroxides. Please list them now.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Were you able to remember the chemical properties of peroxides? Let us go through them together. Peroxides are powerful oxidizing agents. They react with different substances by losing oxygen. Also, peroxides react with aqueous acids to form hydrogen peroxide. Let us now discuss an experiment that will help us distinguish peroxides from other oxides. To begin, 3 beakers are needed. In the first, 20 grams of potassium iodide are dissolved in water to prepare a 250 milliliter solution. In the second beaker, 2 milliliters of concentrated sulfuric acid are diluted in 18 milliliters of water. In the third beaker, a starch solution is prepared by boiling 1 gram of starch in 100 milliliters of water. 50 milliliters of the potassium iodide solution is poured into 4 additional beakers. Then, they are each acidified by adding 5 to 10 drops of the dilute sulfuric acid. Into the first of these new beakers, a spatula of either calcium oxide or magnesium oxide is added. Into the second, aluminium oxide, zinc oxide, or lead oxide is added. Sodium peroxide or barium peroxide is added to the third, and phosphorus pentoxide to the fourth. Finally, about 5 milliliters of the starch solution is added to each of the 4 beakers. Color changes will begin to occur in one of the beakers. For example, when sodium peroxide or barium peroxide is added to the third beaker, the brown color of the iodine appears. This is because the iodine ion oxidizes to iodine molecule. When the starch is added, the solution turns blue. Students, please write the balanced chemical equation for this change.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to balance the chemical equation? Your answer should look like this. Potassium iodine plus sulfuric acid plus sodium peroxide reacts to form potassium sulfate, sodium sulfate, iodine, and water. In today's lesson, we learned about neutral oxides and peroxides. We learned that neutral oxides are oxides that react neither with acids nor with bases to form salt and water. Peroxides are different from other oxides in the oxidation state of oxygen they possess. In our next lesson, we will learn about the various definitions of acids. This brings us to the end for today. Until next time, thank you, teacher. Thank you, students.